Okay, fine. Good morning to all. So I think now we are heading towards shockwave. The entire thing, I mean, whatever we discussed about oscillations, almost all of them are done. Okay, so now we will be heading to the second chapter on module 1, which is related to shock waves. Okay, so shock waves plays a very important role in aerodynamics. So therefore today, what are the things we'll be discussing? So today we will be discussing the following. So this will be the overview of the topic. So with respect to shock wave, what are the things we'll study? Today we will see the overview is, so today we will see how the sound waves are classified. Then we will give the description of a shock wave. Then we'll discuss the basic conservation laws. Then we'll look at few applications of shock waves, construction and working of ready shock tube. We will do it in the next class. Okay. So therefore, shall we get started? Okay. Okay, Pa. So before that, let me start with some videos. Okay, so look here. This plays a very important role in aerodynamics. Okay, Pa. So this is a video in which a jet is moving at a very fast pace. Okay, so when it moves at a speed which is much higher than the speed of sound, when it moves at a speed higher than the speed of sound, it produces a what you call shock waves. Shock waves are nothing but they are produced when when a medium is subjected to sudden expansion of gas. Okay, so therefore let us look at some instances, some aspects of this video. Okay. Natural sounding text-to-speech software online. Hey, I'm Joey, and I'm one of the 30 AI voices from speech. A sonic boom is created when an object travels faster than the speed of sound. Although technically a sound wave, sonic booms can also be accompanied by a visual component, and that's what. See, can you see here in this in this video, that is there is a jet is moving at a very fast, at a very high speed. Okay, high speed means it may be roughly around 3 times the speed of sound. Okay, and you see that there is some a white cloud of water vapor is there, or white I mean there is a layer of white gases around it. Okay, these white gases are nothing but what? They are shock waves. Okay, they are shock waves. So this is what we call it as shock waves. Okay, once again look here. Yes. And that's what we're exploring today, the top 5 sonic booms caught on video.
So good to see all of you after all these years, huh? Remember the good old days when we were...
Okay, can you see here a white color cloud? I mean, a white water vapors or white gases of white color in nature. They are around the tail of the aircraft. So this gas, we call it as what? We call this as shock waves. Okay. Yes. Okay. Now you can see that it looks like a peacock feather, white in color. Okay. So therefore, this is shock waves. Okay. 1 second. I think we'll play the last 10 seconds of the video. Okay. You can see that as the plane moves, the white color, the shock waves, which is white color behind the tail. Okay. So that becomes more and more pronounced. More and more, the visibility becomes more and more clear. Okay, as it approaches near the cameraman. Okay, you can see that it is very nice to look. This is shock waves. Okay, we'll play from 6 seconds. Yeah, here this is again one more instance where can you see in this photograph that it leads to sudden expansion of gases, that white cloud, that we call it as what? Shock waves. Okay, once again see. Okay, again you can see this is shock waves. So this is just produced only for a fraction of a second. That's it. Okay, and these we call it as what? Shock waves, which is formed due to sudden expansion of gases when the medium is subjected to sudden compression or sudden expansion of gases by some mechanism. Okay, it could be due to fast moving object. I think people got some idea about what is a shock wave. So I think I'll close this. Yeah. Okay, so okay, this is what I was telling in the I was showing it in the figure. Okay, so this part was I was referring to the figure. So there is a white cloud that is formed behind the tail of an aircraft. So you see that, so why it is formed in the tail? Because the speed of the object is so high that the sound is going to be behind the object. So when the medium is subjected to sudden expansion of gases, it leads to formation of these waves, which we call it as shock waves. Okay, so those details are what we are going to study here. Okay, so once again, suppose I print the screen. Paint. Okay, can you see in my figure? I was referring to this medium behind the aeroplane, which is white cloud. They are called as shock waves. That you see that is visible only for a fraction of a second. Okay, so I think now we will move on with this. Close this. Okay, pa. So therefore, so today we will be discussing about shock waves. Okay, now, so it is based on what? It is nothing but the study of sound. Okay, now, So what is the overview of today's talk or today's lecture? We will see how the sound waves are classified. We will give the description of a shock wave. Then we will look at the basic conservation laws. Then we will look at the application of shock waves. Construction and working of Reddy shock tube will be taken up in the next class. Okay. Now let us begin. So first, look here in aerodynamics. So aerodynamics means what? In aerodynamics, we'll refer to the study of motion of aircrafts. Okay. So in aerodynamics, the speed of an object is always compared with the speed of sound in a given medium. Okay. So based on this, there is one concept called Mach number. Okay. So what is Mach number defined as? Mach number is defined as the ratio of the speed of an object. Mach number is defined as the ratio of speed of an object to the speed of sound in a given medium. Therefore, what is the formula for Mach number? You can see the formula is written here. Okay. I think if I use mouse, the slide changes. Okay. So therefore, as I read the text, kindly observe. What is the formula for Mach number? Mach number is given by m is equal to speed of the object divided by speed of sound in a given medium. So generally we denote it as V by A. Okay. Next. So what is the formula for speed of sound? So we know that the speed of sound in a given medium, it increases with the temperature as square root of T. Okay. Also, it depends on the nature of the medium. The nature of the medium is characterized by what you call gamma. So the speed of sound A in air or any gas medium at a temperature T is given by A is equal to square root of gamma into RT, where gamma is the ratio of two specific heats. So that is going to be Cp by Cv, which we encounter in thermodynamics. Then R is an universal gas constant, and temperature is T is going to be temperature. Obviously, all quantities are going to be in SI units. Therefore, the temperature is going to be in Kelvin. Okay. Next. So based on, so as I already told, sound requires a medium to travel. So it is also a wave. Therefore, it is characterized by three parameters. Any wave or any disturbance that is propagating in a medium is characterized by three parameters. They are amplitude, phase, and frequency. Okay. So likewise, depending on the frequency range and depending on the amplitude, so sound waves are classified into four categories. They are acoustic waves, ultrasonic waves, subsonic waves, supersonic waves. Okay. Then hypersonic waves is a special class of supersonic waves when the Mach number happens to be very high, like 5. Okay. Now what are acoustic waves? So what are acoustic waves? Look here. Acoustic waves are something that are audible to human ear. So what are acoustic waves? Acoustic waves are the sound waves that are produced by objects that is moving at a speed of 330 meters per second in air at standard temperature and pressure. And we all know about the audible range of our human ear. What is that? The acoustic waves will have a frequency between 20 hertz to 20,000 hertz. Then the amplitude of acoustic waves are going to be very much small. Okay. All these things are compared with respect to the motion of jet. Okay. Therefore, in aerodynamics, what are acoustic waves? The amplitude of acoustic waves are going to be small. Okay. Next, what are ultrasonic waves? Ultrasonic waves are sound waves or pressure waves that are generated that have a frequency that is beyond 20,000 hertz. Okay. The amplitude of ultrasonic waves are going to be very small. Then the speed of ultrasonic waves is again going to be around 330 meters per second in air at standard temperature and pressure. Okay. And we all know about ultrasonic waves. See, for example, when tsunamis are produced, so many animals will be able to sense the arrival of tsunami much before what can be seen, roughly some 3 to 4 minutes. Okay, because ultrasonic waves are those sound vibrations whose frequency range is going to be around 35 35 kilohertz, which is not audible to human ear, but it is audible to other animals. So therefore, other animals can sense the arrival of tsunamis some 5 minutes before it could be seen by human beings near the beach. Okay, therefore what happened was, whenever tsunamis were about to arrive, so many animals which sensed that something is wrong somewhere, they ran away from the shore. So therefore, when the tsunamis arrived, when the tsunamis hit the shore, so later what one found was the number of animals that expired or that died due to tsunami was found to be less in number. Okay, that is because tsunamis, the animals are able to sense the arrival of tsunami 5 or 6 minutes time in advance. Okay, that is because they have the ability to hear the ultrasonic waves, those sound vibrations that are produced when tsunamis or about to arrive. Okay, so again, tsunamis are also just sound vibrations, or it is waves. So as that pass through earth, that will be audible to other animals but not human beings. Okay, so we can detect only through tsunami warning system. Okay, next, so acoustic waves we have discussed, ultrasonic waves we have discussed, and we also know about ultrasonic waves. So one more thing is what bat can detect. Bat, although it is blind, it can detect obstacles as it navigates, as it flies. Okay, because it produces ultrasonic waves. Based on those echoes that are produced, it can make out the obstacles, and it can move in such a way that it can avoid collision of obstacles that is coming during its motion. Okay, next, what are subsonic waves? So subsonic waves are the sound mechanical waves produced by object in a fluid that is moving with a speed. Yes, someone wants to tell something. Someone wants to tell something. Okay, I think my approach is always nice to use paint. Okay, yeah, I think now I can, this is visible, right? Yeah, this should be better. I can highlight whenever I want. Okay, look here. Now let's move on to subsonic waves. What are subsonic waves? So these are the mechanical waves that are produced by objects that is moving in a fluid with a speed that is less than the speed of sound in a given medium. So such waves are referred to as what? Subsonic waves. So if the speed of sound is less than if the speed of the object is less than the speed of sound, then what will happen? We will have m will be Mach number, m is going to be less than 1, or speed of the object is less than the speed of sound. Okay, v denotes the speed of the vehicle, a denotes the speed of the object. What is the example for this? The example for this is the motion of passenger aeroplane. Okay, motion of passenger aeroplane or motion of a car. Okay, all these are going to be less than the speed of sound. Okay, in that case I think some figure is there in future slide, so let me show that this is done. Yeah, let me look at this figure. So if I take this figure, yes, here this is nice. Okay, okay, can you see here? I go for my paint. Yeah. Okay, so now can you see here? In this case, this is subsonic waves. Okay, this is subsonic waves. So what is subsonic wave? So here this is the subsonic wave. You can see that the speed of the object is v. V is less than the speed of sound. Sound is denoted by a. Okay, so these are what sound vibrations that are going to expand as time lapses, and as the object moves forward. For example, passenger aeroplane, or for example, motion of a car. Okay, so in this instance, what happens? The sound vibrations are going to be what has been shown by circle here. These are nothing but what? They are sound vibrations that are expanding with time. Okay, so you see that in this case, what happens? The sound vibrations are before the object. Sound vibrations are before the objects. What does that mean? Can you see here? There are some 3 waves that are shown here. These are before the object. So therefore, if the speed of the object is less when compared to speed of sound, then the sound is going to be in front of the object. Okay, this is clear. The sound vibrations that are produced as shown here. Okay, so roughly some 3 circle or 3 ellipses are shown here. These are called as what? Subsonic waves. Okay, clear? So what are subsonic waves? Subsonic waves are the sound vibrations that are produced by the object. Subsonic waves or the sound waves that are produced by the object that are moving with a speed that is less than the speed of sound in a given medium. Okay, so therefore Mach number m is going to be less than 1. Okay, and it has been highlighted here. Okay, if I go to my paint text, paint figure, paint text, yeah, you can see here that the speed of the object, so here it has been highlighted. The speed of sound will move ahead of the object. Okay, that I have clearly illustrated in the figure. Okay, I think I don't want this paint. This is not required. This slide is over. This is done. And this is, let me be here. Okay, now this is my slide. Okay, this is clear. So sound waves are classified into various categories. So acoustic waves, ultrasonic waves, and subsonic waves we came across. Subsonic waves is particularly, it is considered in those instances where you are referring to motion of an aircraft, particularly the passenger plane. Okay, next, what are supersonic waves? Okay, so this is what the figure I have written. So you can see here that this is the figure. Yeah, this is what I think, this is paint. Yeah, nice. Okay, so this is subsonic waves, and supersonic waves are going to be this. So let us look at the definition of supersonic waves, and then I will talk. Okay, so this is what the same thing is what I have pasted it in the paint. Okay, so this is subsonic waves, this is supersonic waves. So what are supersonic waves? Okay, what are supersonic waves? For example, if I copy this and put it in, okay, I think now it is visible. So what are supersonic waves? So these are the mechanical waves that are produced by objects that is moving with a speed that is greater than the speed of sound in a given medium. Okay, look here, the speed of sound is 330 meters per second in air at standard temperature and pressure. Suppose you consider an object that is moving with a speed which is twice the speed of sound. Twice the speed of sound means roughly 660 meters per second. In that case, what will happen to the Mach number? Mach number will be 2, or Mach number is going to be greater than 1. So in that case, what will happen? If the object moves at a speed greater than the speed of sound, sound is going to be behind the object. Okay, so the sound emitted, look here, the sound emitted by the object, so that will be behind the object. Okay, that is what is clearly illustrated in this figure. Can you see here? If I take, can you see here? Yeah, so look here, this aeroplane is somewhere here. This is the point where an aircraft is located. You can see that the sound vibrations are behind the aeroplane, and as time lapses, what happens? The sound vibrations are expanding. Okay, the circle is becoming bigger and bigger. The object is moving forward. It is moving forward. Okay, right? So what are subsonic waves? In the case of subsonic waves, if the object moves at a speed which is greater than the speed of sound in a given medium. That is, Mach number will be greater than 1. For example, Mach number being 2. If an object moves at a speed of 660 meters per second, m will be equal to 2. In that case, what will happen? The sound vibrations are going to be behind the object, and the sound vibrations are going to expand as time lapses. Okay, so this kind of waves we call it as what? Supersonic waves. Okay, this kind of objects we call it as what? Supersonic waves. Okay, this is what we call it as supersonic waves. Okay, next there are two important concepts related to this. They are Mach cone and Mach angle. Okay, two important concepts are associated with supersonic waves. They are what? One is Mach cone and the other is called Mach angle. Okay, now what is Mach cone? So before that, I think I'll focus only on this figure now. So this is my paint. Yes, all the stuffs we do. Yes. Okay, look here. I think I'll just zoom. Yes. So what I want only supersonic zone. Yes. Okay, look here, pa. Fine, nice. Okay, yes. Okay, this is what I will be now focusing on. I'll be just focusing on only this part. Okay, so for example, if I highlight this, okay, only this is what I'll be focusing. Okay, so this is supersonic waves. Okay, now look here. What is Mach cone? Definition of Mach cone. See, if a number of common tangents are drawn to the expanding sound waves emitted from a body at supersonic speed, moving at a supersonic speed, so it forms a cone. So such a cone is called as a Mach cone. Okay, what does that mean? What does that mean is the following. Okay, can you see here? Suppose I use a green color. And yeah, can you see here? The sound vibrations are expanding. The sound vibrations, as time lapses, they are expanding with time. Okay, this is what you see as some 4 circles are given. Okay, so this is a circle which is very close to the plane. This circle is quite far. Okay, now look here. So if I draw, what do you mean by tangent? Tangent or a straight line that is going to touch your circle only at one point. Okay, now look here. Suppose I use red color. Yeah, look here. So what is this? This is an straight line that touches each of these circles only at one point. Okay, so what is the locus of this point? Locus of this point, it is the equation of direct common tangent. So I can draw a tangent, one above and one below, like this. Okay, this is the first tangent and this is the second tangent, or this is the tangent 1 and this is tangent 2. Okay, and you see that all these sound vibrations, can you see here? Suppose I use, say, violet color. All these sound vibrations are confined to be within this cone. They're supposed to, they are confined within this cone. This cone that is described by an object that is moving at a supersonic speed, we call this kind of cone as what? Mach cone. Okay, once again I'll give the definition of Mach cone. Okay, to draw Mach cone, what are the things required? First thing is, you require an object to move at a very high speed where the Mach number is going to be greater than 1. For example, 2, 3 or 5. Next, you will consider the locus of the direct common tangent of each of these waves. So that is going to be a straight line in this case. Okay, so the sound vibrations are confined within this cone. Therefore, this cone, I call it as what? Mach cone. Okay, so what is the definition of Mach cone? If I undo all these stuffs here, what is the definition of Mach cone? A number of common tangents that are drawn to the expanding sound waves emitted from an object at supersonic speeds. So it will give rise to a cone. Okay, it gives rise to a cone. You can see here clearly, this is a cone. Okay, this is a cone. Okay, all sound vibrations are confined to be inside this cone. This cone I call it as what? This cone we call it as Mach cone. Okay, Mach was a first scientist who investigated these aerodynamics applications. So therefore, this cone is named after him. Okay, so this is clear. So what is Mach cone is clear. Okay, next we will look at Mach angle. So what is Mach angle? Okay, look here, what is Mach angle? It is the angle mu made by the tangent with the axis of the cone. So it is called as Mach angle. So I'll put it, I will illustrate this geometrically. It becomes easy for you to understand. Okay, so let me undo all unwanted things. Yes, okay, look here, it is clear. What is that? It is clear that this is the direct common tangent. Okay, this is the direct common tangent lying above and below as shown in the figure. Okay, now look here, suppose I draw a line. Can you see here? What is this dotted line refer to? This dotted line refer to the path traveled by an aircraft. In this example, aircraft is moving towards left. Okay, in this example, the aircraft is moving towards left. What direction is the aircraft moving? Aircraft is moving towards left. Okay, now look here. So what is this? What is this dotted line refer to? Or dotted line refers to the axis of the cone. Okay, this is the axis of the cone. So if I find this angle, okay, we may call it as alpha or alpha by 2. Look here, this whole thing is going to be 2 alpha. Therefore, this region is going to be alpha. Okay, therefore, what is Mach angle? Mach angle, someone wants to join. Okay, what is Mach angle? Look at the definition here in the PPT. I go to pane 2. Yes. So what is Mach angle? Mach angle is the angle, we denote it by mu, the angle made by the tangent with the axis of the cone is called Mach cone. Okay, and it is going to be what? Half the angle, half the cone angle. Half the cone angle means that is what I told. Okay, so that is what I told. If this whole angle I call it as angle of cone, half of that is this angle. Okay, once again I'll repeat. Don't worry. Let me first define what is Mach angle. Mach angle is nothing but what? If I use black color, if I use, for example, black color. So what is Mach angle? The angle made by the tangent along the axis of the cone. This angle we call it as what? Mach angle. Okay, the angle made by the tangent along the axis of the cone is called as Mach angle. So this angle alpha is half of this. Okay, alpha is equal to half of this angle. Okay, clear? I think the idea is clear. Once again I'll repeat. What is Mach angle? I'm using black color. So Mach angle is nothing but what? The angle made by the direct common tangent with respect to the axis of the cone. This angle is called as Mach angle. We may denote it as alpha or mu. I think we have denoted it as mu. So I will write it as mu. Okay. So this Mach angle will be related to the speed of the object. So speed of the object means it will be related to Mach number. Therefore, it is given by what? Mach angle is given by, so mu is equal to, so the formula for Mach angle is mu is equal to sine inverse of 1 by m, or sine mu is equal to 1 by m. Okay, so therefore this is a formula. Okay, next I think hypersonic waves are there. It's not there in this. Yeah, hypersonic waves are there. So what are hypersonic waves? Okay, understand. Hypersonic waves are hypersonic waves Hypersonic waves are the mechanical waves or sound vibrations that are produced by objects that is moving with speed that is greater than 5 times the speed of sound in a given medium. Okay, for example, if an object moves at a speed of 6 times the speed of sound, 6 times the speed of sound means 330 meters per second, 6 threes are 18. So if an object is moving at a speed of say 2000 meters per second, okay, then the sound vibrations that are produced, they are called as hypersonic waves. Okay, why they are called as hypersonic waves? Understand here. If I go to this original figure, yeah, undo all these stuffs. Okay, can you see here, when the speed of an object, happens to be say 2, m equal to 2, the locus of direct common tangent is going to be what? A straight line. Locus of the direct common tangent is going to be a straight line. Okay, on the other hand, if the Mach number happens to be greater than 5, okay, in that case what happens? In that case, this locus of direct common tangent, okay, I will erase this. The locus of direct common tangent, this is going to be what? An hyperbola. Okay, the locus of direct common tangent is going to be what? An hyperbola. Okay, so therefore the waves that are sound vibrations that are within this cone, we call it as hypersonic waves. Okay, once again I will repeat. Look here, if the speed of an object is very small, then the locus of direct common tangent is going to be a straight line. Okay, straight line. On the other hand, if the speed of an object happens to be 5 times the speed of sound or 6 times the speed of sound, then what will happen to the locus of direct common tangent? The locus of direct common tangent is going to be an hyperbola. Therefore, the sound vibrations that are confined within this hypercone, we call it as what? Hypersonic waves. Okay, clear? No? So this term hypersonic waves is related with hyperbola. Okay, hyperbola. Okay, that we encounter in conic section. So therefore the speed of, so we came to know about the definition or concept of hypersonic waves is also clear. Okay, now let us move on to the original slide. Okay, so this is clear, and here this is again one more instance. Here what is this? This is again in one more instance. You see that it is an hypersonic wave. Hypersonic wave means what? Suppose I print it, put it in. Okay, that is what I was telling. Okay, what is this? This locus of direct common tangent is going to be what? This locus of direct common tangent, this is going to be an hyperbola. Hyperbola means, for example, xy equal to a constant. Okay, so this is, so sound vibrations that are within this cone, we call it as hypersonic waves. Okay, and several things are given. Okay, technically speaking, this locus of direct common tangent, we call it as shock wave. Okay, fine. I think this figure also is clear. So this is hypersonic waves. Okay, so where is my cursor? Yes, this is done. I think I'll close this. Okay, next. Supersonic waves, hypersonic waves, this is clear. This slide is done. I go to shock waves. Yeah. Okay, what are shock waves? Okay, look here. So what are shock waves? So again, I'll do the same thing. Copy this and put it in my whiteboard. Close this. Okay, now look here, Pa. What are shock waves? So what are shock waves? Look here. Any fluid that propagates at supersonic speeds, so it gives rise to a shock wave. Shock waves are what? These are nothing but a compressed regions. Okay. So shock waves are produced in nature during earthquakes. Then when thundering sound is produced during rainy season. So in these instances, shock waves are produced. Okay. Now what is the technical definition of shock waves? So when are shock wave produced? Shock waves are produced during earthquake. These are produced during explosion of atomic bombs. Then when lightning occurs during rainy season. Okay. So once lightning occurs, after that there will be thundering. Okay. So what is the technical definition of shock waves? So a shock wave is a surface that manifests as a surface of discontinuity in a fluid medium in which it is propagating with supersonic speed. Okay, once again I'll read it again. What is the technical definition of shock wave? A shock wave is a surface that manifests as a surface of discontinuity in a fluid medium in which it is propagating with a supersonic speed. Okay, what does that mean? What does that mean? I think I will take this figure, the earlier figure. I hope this is paint. Yeah, let me take this figure. Okay, now can you see here? What is shock wave? Shock wave is a surface of discontinuity that occurs when an object is moving at a supersonic speed. Okay, look here. So what is the locus of our direct common tangent? The locus of direct common tangent is this. Correct? No, this is the locus of direct common tangent. Okay, technically speaking, this is nothing but it is going to be a region which is highly compressed. It could be of the order of few micrometers. Okay, so as the plane is moving, as the plane moves towards left, okay, as the plane moves, what happens? You see that the plane is going to heat the gas medium, or it is going to increase the pressure, temperature and density of the gas medium. Okay, therefore what does that mean? What does that mean is, look here. So I will write this as, this is my direct common tangent. So if I denote, okay, in the region which is very close to this direct common tangent, if I denote the pressure, density and gas by say P1 rho 1 and T1. Okay, what are P1, rho 1 and T1? These are the pressure, temperature and density which are very close to this shock region. Okay, I will indicate it by blue color. Okay, so what do you see? The pressure, then the density and temperature of the gas in this region. No, it is going to be very much high when compared to what you see in the outside this cone, outside this region. Okay, that means what? The pressure here is going to be very high when compared to the pressure of the gas outside. The density is going to be very high when compared to the density of gas outside the cone. The temperature at this point is going to be very high when compared to what do you see in the surroundings. So therefore this manifests as what? A surface of discontinuity. Discontinuity in calculus, what do you mean? Left hand limit is not equal to right hand limit. What does that mean? Near this region, okay, near this region, pressure P1 is very high when compared to the pressure that is existing in the atmosphere. If I denote it as P2, so P1 minus P2 is going to be high, which is not zero. Likewise, T2 minus T1, okay, the temperature outside the cone is going to be small when compared to what is there at this. So therefore this line of discontinuity, this surface of discontinuity, we call it as what? shock waves. Okay, and generally the thickness of that shock wave is going to be extremely small, of the order of few micrometers. That is what you had been seeing in that video that I showed. It leads to sudden expansion of gases. That gas is nothing but what? The thickness of the shock front. Okay, so therefore what is, once again I will recollect, what is the definition of shock wave? A shock wave is, so what is the definition of shock wave? A shock wave is a surface that manifests as a surface of discontinuity. Surface of discontinuity means what? Left hand limit is not equal to right hand limit. Okay, so what does that mean? So what does that mean is the temperature is going to be very high here in this locus of direct common tangent. Okay, so the such a surface of discontinuity that exists in a given fluid medium when the object is moving at a very high speed, we call it as what? Shock wave. Okay, what are shock waves? Shock waves are the surface of discontinuity that occurs when an object is moving at a supersonic speed. Supersonic speed means what? Mach number m is greater than 5 times the speed of sound. Okay, in that case you are going to get hyperplane and so on. Okay, fine. Okay, so I think this is fine. So I'll close this. This also I'll close. If it's required, I'll retain. Next, I'll minimize the window. Okay, so definition of shock wave and the technical definition of shock wave, both are done. What is there next? So you can see this is what I was telling. Okay, so here you see that this is the shock front, okay, which is there behind the object. Why it is there behind the object? Because the object is moving at a very high speed when compared to sound. Therefore sound is going to be behind the object. Okay, sound is going to be behind the object. And here in this figure, in orange color figure, you see that two jets are moving in the neighborhood, and because of the movement of two jets, two separate cones are produced. Okay, so this is done. Okay, next, how can we produce gas, or how can we produce shock waves? Okay, so how you can produce shock waves? Shock waves can be produced by sudden dissipation of mechanical energy in a medium enclosed in a small space. Okay, for example, if you clap your hand, correct? No, if you clap, what happens? The medium is subjected to sudden expansion. Okay, so shock waves can be produced by making the medium to expand suddenly by some mechanism. Okay, it could be by making the object to go at a very high speed, or by compressing by some mechanism, by some means. Okay, once again we'll recollect what are shock waves. Shock waves can be produced by sudden dissipation of mechanical energy in a given medium that is enclosed in a small space. Okay, that is, make the medium to expand suddenly by some mechanism, then temperature, pressure and density is going to be high in a small region. So that we call it as what? Shock waves. Okay, next, within a shock wave, the pressure, temperature and density of the gas will undergo a large change, which we call it as instantaneous changes. Instantaneous means what? Turant. Ati shigra. Okay, instantaneous means what? At right now. Okay, so within a shock wave, what happens? The pressure, temperature and density of the gas will undergo instantaneous changes. Okay, that is what I was referring to in that locus of the direct common tangent. The thickness of the tangent is going to be very small, but within that small region, the density, pressure and temperature of the gas is going to be very high. Okay, so therefore what does that mean? What does it boils down to? So a shock wave is characterized by sudden increase of pressure, temperature and density of the gas through which the object is moving. Okay, through which the objects producing the sound waves is moving. Okay. Next, what do you mean by sonic boom? So if a bomb explodes, what is the sound we get? We hear the sound as boom, hum. So that sound we call it as what? Sonic boom. So what is a sonic boom? A shock wave by itself cannot be heard. What you hear is the booming sound of the word. Okay. So if the bomb explodes, right? So it is not the sound of a bomb. It's actually the booming sound of the expanding gases. Okay. So we hear the booming sound as the velocity of the object increases from subsonic region to supersonic speed. Subsonic means what? Mach number is less than 1. Supersonic speed means what? M is greater than 1. So if the body accelerates from lower velocity and if it crosses the speed of sound, then you hear the sonic boom, which is nothing but the sudden expansion of gases. Okay, which is a consequence of the sudden expansion of gases. Okay, so this slide is done. What is there next? Okay, and how many types of shock waves are there? There are two types of shock waves. One we call it as strong shock waves and the other we call it as weak shock waves. Okay, so if I take again paint, how many types of shock waves are there? There are two types of shock waves. They are strong shock waves and weak shock waves. Okay, so in strong shock waves, what happens? Strong shock waves are produced. Strong shock waves are produced. If the in strong shock waves, what happens? The compressed regions will possess a very high value of pressure, temperature, and density. Okay, so for example, this will occur when thunder is produced during rainy season, or when nuclear explosion occurs, or when there is nuclear bombs explode. So these are examples of strong shock waves. Strong shock waves means what? Within that compressed region, the value of density, temperature, and pressure is going to be very high. Okay. On the other hand, if you take, for example, the bursting of a cracker, or if an automobile tire bursts, if that explodes, then that is what they are characterized as weak shock waves. Okay. What are weak shock waves? In weak shock waves, the compressed region, the value of inside the compressed region, the value of temperature, pressure, and density is going to be small. These are produced by objects that are moving with a Mach number which is close to 1. That is, with whose velocity is close to the speed of sound in a given medium. What are the examples for that? The explosion of cracker and the bursting of an automobile. So these are examples for weak shock wave. Okay, so this is done. This is done. Let me close this. Okay, types of shock waves is done. Then basic conservation laws. After that, I will stop. Okay, so basic conservation laws. Okay, look here. Go to next page. Yeah. So there are three laws. Okay, they are law of conservation of mass, momentum, and energy. Okay, law of conservation of mass and momentum. We would have, the law of conservation of momentum and energy we have already encountered in physics. Okay, during elastic collisions and inelastic collisions and so on. So what are the three basic laws of conservation laws? The three basic conservation laws are law of conservation of energy, momentum, and energy. Okay, energy, momentum, and mass. Okay, so what is the law of conservation of momentum? So in any closed system, the total momentum before collision will be equal to total momentum after collision, or the total momentum will remain constant. Okay, so anything that is maintained at a constant value, we call it as what? Conservation. Okay, for example, number of trees is decreasing. So therefore, to increase greenery, what you have to do? You have to plant more trees so that the number of trees at any given point of time that is maintained at a constant value. Okay, that's what you mean by law of conservation. Okay, law of conservation of momentum is clear. Now what happens in the case of law of conservation of energy? The total energy of a closed system or an isolated system is going to be constant, whatever changes that may occur within the system. Okay, so that is done. Next is, what is law of conservation of mass? So the total mass of any isolated system is going to be constant, although there may be lot of physical and chemical changes that are occurring within a system. Okay, so these are three conservation laws. So in the next class we will move on to the construction and working of ready shock tube and the applications of shock wave.